Hey guys, today is day 57 or 58. I'm not really sure of my algorithms video. Uh, I told you guys yesterday that I'm going to bring a medium level difficulty question for the 2 pointers. And um, yeah, I was trying to solve it and I couldn't solve it. I looked at the solution and it said to utilize 2 pointers using this algorithm called Floyd's hare and tortoise algorithm. And it was the first time using it for me, although I knew the existence of fast and slow pointer. Um, so I just wanted to briefly talk about it and also explain how it works using um, the code for this problem. So let me just share my screen. Before going on to the problem, I'll just briefly describe what this detection algorithm is. So this hare and tortoise algorithm is also known as Floyd's cycle algorithm. So it is used to detect whether there is a cycle in an array or linked list, and to see what is the starting point of that cycle, and also what is the intersection point of the cycle. This intersection point meaning that when we utilize 2 pointers, so as you can see, there's going to be a hare pointer and tortoise pointer used in this algorithm. Hare is a pointer that traverses the array or linked list twice as fast as the tortoise. So therefore, if there is a cycle, then at certain point, they will meet. So that is the intersection point. Um, so starting point is, and also starting point is where we enter the cycle. And that we're gonna also look at. And that is usually found when with the tortoise pointer. But we're gonna see how that works using the problem. So the main constituents of this algorithm, so steps for the algorithm is, first we have to initialize. Like always, we have to initialize the 2 pointers, and in just this case, we just have to initialize hare and tortoise. And then we have to move the algorithm. So for tortoise, we know that we have to move 2 steps forward. No, 1 step forward. And for hare, we have to move 2 steps forward. And third, so we're talking about the steps, how we're going to use this algorithm to solve the problem. 3 is to detect the cycle. So if there is no cycle means that the hare will reach the end of the sequence of the array or linked list without meeting the tortoise. So reach the end of the sequence without meeting tortoise. And if there is a cycle, yes, cycle, then hare will meet tortoise inside the cycle, right? While it's going through. The fourth step is finding the cycle start of the cycle, finding the start of the cycle if needed in the problem. So once the hare and tortoise meet inside the cycle, then it means that the cycle is confirmed. And to find the starting point of the cycle, you move one of the pointers, and most of the times it said it's usually the hare that we move back to the start of the sequence. So move hare back to the start, and now move both pointers 1 step at a time. And the point where they meet again is the start of a cycle. So move both pointers 1 step at a time, and the point they meet is the start of the cycle. right? So let's look at this using an example. So let's say that there's a linked list of 1, 2, 3, 4, 5, 6, and then 3. So with our naked eye, we can already see that the cycle starts again at 3. So T is a tortoise pointer and H is the hare pointer. Tortoise starts at 1, and then hare also starts at 1. Now, first move, you can see that tortoise will go to 2, T is 2, and hare will go to double step, so it's going to be 3. Second, it will go, tortoise will go to 3, hare will go to 5. Third move, the tortoise will move to 4, and then hare will move back to 3, which is the yeah. Now, the fourth move. Fourth move. Here, the tortoise is still gonna go to 5, and then hare, because it's gonna move 2 steps, is gonna go back to 5 as well. So here we know that they will meet, which means that there exists a cycle. Hare will meet tortoise inside, right? So we did until step 3. We initialized 2 pointers, we moved the algorithm, and at this point, we saw that hare met the tortoise, so there is a cycle detected. And now, since we found the intersection, we also want to find the starting point in some cases, which we will later show that that's a case for that question that I try to solve. So how are we gonna find the start of a cycle? We saw that we move hare back to the start. So we usually move the hare. So we leave the tortoise pointer at 5 and we move the hare at 1. And now if we go to the next step, the hare will go to 3, and then the tortoise will go to 6, right? We move one step further, and then hare will go, no, wait, I'm sorry. We saw that both pointers one step at a time. So at this, when we start from the beginning, when we start the hare from the beginning, we only move one step at a time. So we move to 2, and then hare moves to 6, and then the tortoise moves to 6, and we move the hare to 3, and tortoise move to 3 as well. So now we see that at 3, they meet. So that means that's the start of the cycle. So we found the intersection of the cycle, and then we moved the hare pointer to the start, and then we moved both pointer one step at a time. And then we saw that they meet at 3. So that means that it is the start of the cycle. So let's try to implement this algorithm in this question. Find the duplicate number. So given an array of integers nums containing n plus 1 integers where each integer is in the range 1 to n inclusive, there's only one repeated number in nums. Return this repeated number. You must solve the problem without modifying the array nums and use only constant extra space. So what I initially tried to do was sort this array and then initialize 2 pointers to iterate through the array. But given the constraint that we shouldn't modify the array nums, we cannot use the sort, right? So that method was a failure. From the test case 1, we can see that there's a duplicate number 2. So that means that the duplicate number is 2. Here we can already see from the naked eye that 3 is duplicated. So that means the output is 3. Same goes for your test case 3, 3. So output is 3. So how are we going to implement this using code? we first initialize 2 pointers, like from step 1. So slow equals to num0 and fast equals to num0 as well. So we start from the 0th element of the array, and we do the while loop. So first while loop is while true. While true, slow equals nums slow. So now we're moving the algorithm. So fast equals, we're initializing how fast both slow pointers and fast pointers will go. The hare and tortoise in Floyd's algorithm. So fast, no, nums fast. Though this shows that slow is going 1 step at a time, and fast is going 2 steps at a time. And if they meet up in the cycle, that means that the cycle exists, right? So if slow is equal to fast, then we break. Now outside the loop, we do the loop continues. The loop continues until slow and fast meet at the same element, which means that there's a cycle, like what I said. And now we do the cycle detection. So we're thinking each number as pointing to the next number in the linked list, and duplicate number makes the cycle in this linked list. A meeting point of slow and fast pointer confirms that there is a cycle, and after that we reset the pointers. So that will be done by using slow equals nums0, and while slow is not equal to fast, so equals fast equals fast. Let me just finish this. Turn stop. So after detecting the cycle, we reset the oh, wait, this should be fast. We detect the fast pointer to the start of the array, which is num0, like we did here. So we move hare back to the start, and we do the second while loop. So now both slow and fast pointers move 1 step at a time, as you can see here. And then later, this will eventually meet at the duplicate number. And then after that, we return the duplicate, which is slow. So yeah, this should work. Minor mistake. This is a comparison, so there should be 2 equals. Yeah, so this works. As you can see, it has found successfully the duplicate number. So this works because we have formed a cycle to find the duplicate number, and because a pointer points back to a previous number in the array, and using the Floyd's tortoise and hare algorithm, we also detected the cycle, and we detected its intersection and the starting point. So yeah, that was it, guys. It was a very interesting case. I liked how we solved this. Tomorrow we're gonna start, not tomorrow, but then the next time when we do this algorithm challenge, we're gonna do the sliding windows or prefix sum, the question involving either one of those. I think for 2-pointers, we have done quite some questions, so maybe it's time to move on. Anyways, thank you guys all for listening. If you guys have any comments, leave it down below. I'll see you guys next time.